Welcome friends, I am Tanmoy. So you are welcome in my channel Chemistry and History of Molecules, and today we will discuss a question which came in the GATE exam 2011. It's a 1 marks question. So the question is, in presence of acid what happens to this molecule? Means it transforms into X, a major product. What is the correct structure of the major product? So before going to details, I am to say you that initially I will explain this process mechanism completely stepwise. After that we will get the right answer, and in the second part, means second last stage, I will explaining the trick, because you can't spend that much time in exam hall to get the correct answer, then you will not be able to finish all the question. So you need to follow tricks. So I will explain the trick that you can answer within 1 minute. Okay, so let's start. So first of all, what we can see, this main molecule is in presence of acid, produces something, and there are 4 products, and among 4 you can see one common option, that is phenyl. Okay, so this is our first hints. Second is, here acid is given and proton, it's a hard acid. So what is the hard acid in the molecule? That is oxygen. Double bond, sorry, hard base, that is oxygen. Double bond is a base, but it's a soft base. Okay, so oxygen is hard base. First expected that there will be a adduct formation here in presence of acid. What will be the product? Using lone pair, this oxygen will be protonated. Okay. And another important point, to methyl group's position, you must observe this is an angular methyl group. Of course it's tertiary, I believe, but when ring, it is an angular methyl group, and this is a secondary methyl. So this is important, you must keep this factor in mind. So right now this, so after getting protonation, the formal charge goes on oxygen. Okay. So this molecule can have a canonical form. What type of canonical form? This double bond can come here and it can come here. So what is the driving force for this canonical form? So the driving force is oxygen do not have negative charge, instead of carbon has a negative charge, and we know that oxygen is more electronegative compared to carbon. That's why the positive charge of carbon is relatively stable. But one point should be remembered, when there is a factor of octet fill up of every atom, then oxygen will participate. Okay. So actually here what happens, now you see one positive charge is here. Okay. Sorry, I made a mistake in the question. One double bond must be here. So here and here, one double bond should be here. So this is. And second is that one option from here, another option from here. What is? Then double bond must be here. This is here and this. This is OH. Similar reason. This, sorry, and methyl group here and one another here, and the positive charge should be here. Okay. Now if you compare the stability of these two, it's a secondary carbocation. Okay, and it is a tertiary carbocation. Okay, so according to logically this is more stable. So it is expected that in the medium concentration of this tertiary carbocation will be more. It's true. But what will be the next? For example, if this tertiary carbocation is here, one thing, what can migrate? This methyl group can migrate option 1, which will result another tertiary carbocation. Second, what can migrate? This methyl group can migrate option 2, and it will produce ultimately secondary because carbocarbon will be generated here. And another thing, this ring could migrate, but that will not give that much stability because that will again create a crowding situation. And second point, if ring migrates, then it is not possible to have aromaticity, and you can see here every case this benzene got aromaticity. So if ring migrate, this aromaticity will never be achieved because this carbon will be attached to 4 carbon centers, 5. So it will not happen. So third point will not happen. Now if tertiary to tertiary, not that much significant, tertiary to primary, extremely not allowed, means it will not happen. So it is not that much favorable option. Now let's check the another part here. If we consider if here methyl migrates, then it will produce a tertiary, option 1, tertiary carbocation. And another thing, if this bond migrate, I am not saying that it will migrate, but let's check the options. If it migrates, what will be the product? If you see the product structure, it will look like to you also that it is impossible. This is, and this is migrate from here to here. So this bridge head, it will not be favored. Okay. And another thing, why will not be favored? Because there is an option of tertiary formation which is stable. Then why reaction will follow this complicated pathway? Now in this context, you must remember one thing in mind. There should be infinite number of possibility for a reaction. There should be infinite number of pathways for a reaction to produce different number of products. But reaction will follow that path which is associated with minimum extent of energy of activation. So this is called principle of microscopic reversibility. So that pathway will be followed whose corresponding energy of activation is the minimum. So here we can understand, although it is more stable, but ultimately it will not produce any stable thing. But here relatively unstable, but that is another positive factor that it will undergo some carbocation rearrangement to produce more stable. So this pathway will be followed. So let's clean it. So this, now after that a tertiary carbocation will form. So what is happening? This methyl group whole migrating here. What will be the consequence? The consequence is all these double bond hydroxyl unaffected, methyl group is here. And always keep this thing in mind while you are doing any migration. Please don't forget about this hydrogen. This hydrogen will feel bad. And if it feels bad, then you will be misguided. So give some attention to hydrogens also. So this is the methyl, and right now the carbocation's position is this. It's a tertiary carbocation and stable. Okay. And another chance is that, another option, that let's clean it. Another option is that this proton, don't neglect, because if next step base, for example, the solvent molecules which have lone pair, that can abstract this proton and it will come here. So ultimately what getting this molecule is getting aromaticity. Wow. This is Me. This is Me. This is a double bond, newly formed double bond, and this is, and actually this step is minus H plus, means solvent have abstracted the proton. Okay. Yeah, video going on. So this is our product. Okay. Okay. Now let's check which option is matching with this. Methyl and this methyl, this phenolic and methyl 1,3, and this methyl and D. This is. Okay, rest of the thing not. So our answer of the question is answer of the question is, this is the answer. Okay, I guess you have understood. So right now I will explain you the trick how to solve this question within 1 minute. First of all, what you are observing, let's clean it. So it's a fresh. So what you are observing? You are observing that acid is given, heart center is oxygen, so definitely protonation will happen. Okay, protonation. Now it's a carbonyl group adjacent to double bond, so conjugation possible, and 2 position positive charge formation possible. This and this. So now methyl will migrate to give carbocation here. And another thing, if this migrates, that will be a less stable carbocation. Second point, if methyl migrates, there is a proton which ultimately results in aromaticity. This is. So, and how will you eliminate? This is your thinking and process of elimination which will reduce the number of chances. For example, oxygen should not migrate in cations environment, acidic environment, oxygen will not migrate. Here oxygen is migrated, and another, okay, here oxygen migrated, so not possible. Okay, okay. Another thing, these methyl can migrate this side, but not this. So check the methyl position. Here methyl group, 2 methyl come closer, this same direction. So not possible, so leave. So leave. So in this way, see all the options are gone. So if you can follow little trick and common sense, you can, without following the proper mechanistic pathway which consumes a lots of time during examination, you can find out the answer. And this common understanding will be better if you read the basic concepts. So I suggest you always try to understand basic question, basic concept, and if you are confused, ask that question at that time and try to find out the answer. So that may be hard work for you at that time, but later you will be benefited during the examination. So this is the end of the video. So if you like my videos, please give a thumbs up and subscribe my channel Chemistry the Mystery of Molecules, and press the bell icon to get the notification of every new single video I upload. And finally, please share this video among your friends that other people also get benefited from my effort. So thank you everyone. Let's see you in the next video.